Hi, good morning, everybody. This is Eli Shield from GameBench. I'm going to be leading this webinar today. I'm really looking forward to it. Just have a brief question. Could somebody just drop into the chat that whether or not they can hear me and that they can see the first screen? Like I said, it'd be great if you could just drop a message in the chat and let me know whether or not you can hear me and see the screen. Correct screen. And like I mentioned in the chat, we're gonna wait just about 5 minutes to let some folks trickle in, and then we'll go ahead and kick this right off. Okay. Thank you, Morgan, for answering a couple of questions or asking a couple of questions there. I can see that people can see and hear me, which is great. Anyways, my name is Eli Shiel. I'm a principal engineer here at GameBench, and I want to welcome you all to the first of hopefully many webinars around performance matters. So let's just kind of dive right into it, and let's go over the agenda here. Oh, excuse me. So I'm going to do a couple of quick introductions to myself and to GameBench if you're not familiar with the organization. We'll talk about why performance matters. We'll talk about how performance issues reach users and how do we actually fix this? What are the steps that we need to take to catch performance issues earlier in the development cycle of your games? And how do we make sure that what we're doing is quantifiable, repeatable, and actionable? Which gets us into the next two topics around quantifying performance and creating actionable intelligence from the data that we gather. And then at that point, I think we're going to jump right into the future webinar topics, what we want to accomplish over the coming weeks and months in concert with the community here. And then we'll just open it up to some Q&A and any questions that folks have. I'll try to answer them to the best of my abilities. So I think the first introduction we should do is an introduction to this webinar series. This is the first one. Thanks everybody for showing up. I really appreciate it. And what I'm hoping to get out of this from my end is a sense of community and understanding of what people in industry are dealing with and working through when it comes to performance issues. And I hope that for participants in this webinar and people that are listening to the recording, they're getting actionable insight and real solutions to actual performance issues. So let's talk about who I am. My name is Eli Shiel, like I mentioned before. I know it probably says that I'm Ian on the GoToWebinar, but my name's Eli. I'm a principal engineer at GameBench. My primary focus at GameBench is on automated performance management. And in addition to my role at GameBench, I also like doing games development on the side, primarily Unity-based, and I really like kind of experimenting around with XR experiences, AR, VR, mixed reality. So, you know, I'm not just somebody who's building tools. I actually build games and love games myself. And my email address is eli@gamebench.net. If you have any questions after the webinar or have any thoughts that you come up with, please feel free to email me and share those with me, and I would love to chat. And while we're doing this webinar, if you have any questions, feel free to either drop it into the chat or into the question section. And every couple of slides, I'll just make sure that there aren't any, you know, if there are any questions that I'm answering them. So like I said, my email is eli@gamebench.net. If you have any thoughts afterwards, please send them my way. Speaking of GameBench, what is GameBench? If you don't know, we are the leader in game performance management solutions. We build tools for performance management. We work with some of the top tier game studios and QA firms to develop tools to help studios and firms identify where performance issues are coming up in their games. We also have a lab service that is more of consultative services that will help evaluate performance on games with respect to competing titles, give you real performance insights, potential bugs, etc. We've been around since 2013. I'm relatively new to the team, but we're established. We're, like I said, the leader in game performance management solutions. So that's who GameBench is. So the title of this webinar series is Performance Matters. Well, why does performance matter? Well, I think the easiest and best way to look at this is to actually look at real user reviews of some popular mobile game titles. So the first one that I pulled up, we've got this really cool tool that allows us to punch in any Android or iOS application. And then we can pull all of the reviews, or we can pull a bunch of reviews, parse them, and look for certain negative reviews that are around things like performance tags. So this is a slightly popular game. I don't know if anybody's heard of it, called PUBG. And it turns out they have a lot of performance issues. Nearly 15% of their bad reviews are due to just lag alone. It's actually closer to 20% of all of their reviews are negative. And we can click on each of these boxes and drill down into what the actual review text says around each of these issues. So we have lag, server, crash, load, slow, hang, FPS, freezes, battery. Lag is one of my favorite ones with PUBG. There are some real issues around FPS, especially when you use vehicles. So PUBG, I think, is a great example of a game that has some severe performance issues that are impacting users. Pokemon Go is another great game to look at for performance-related issues that users are actively writing reviews about. So we're looking at, in this case, load times. So we can see that Pokemon Go will not load at all, fail to load. My apps just started crashing at the load screen. Again, a lot of really negative reviews that people have taken the time out to actually write a review describing the performance issues they have. And then, like I said, I'm a big fan of AR, VR, anything augmented reality, extended reality. So I pulled up a third title here of Angry Birds AR, Isle of Pigs. And we don't have as many reviews, we only have 263. But when we look at them, we have some battery issues here. And we look down and we can see, this is just Angry Birds, but AR. I'll take that any day of the week, which that's the start of a great review. And then it gets into, it could kind of screw your battery life. I like the game, but it takes so much of the battery life. Love this game, but it drains the battery on my new XS Max about 1% a minute. So we have all these very, very positive reviews that then take a very negative turn because of performance issues. And this is why performance matters. What we're seeing is people love these games. They love them to the point where they're willing to actually write a review out, but they're noticing real technical performance issues and they're complaining about it. And how did this happen? How did we get here? How is this, possible that a big studio like Rovio or a publisher like Rovio pushed out a game that is draining someone's battery at 1% a minute? It's not like the developers or testers saw that and were like, oh, we're fine. And the reality is mobile games have a large number of differences between the sort of development environment and the real world use case. And that causes users to have a completely different experience sometimes than what the game developers, game testers, QA teams, compat teams encounter in the studio and publishing world. So that's kind of a wall of text. One of our analysts likes to talk about mobile games development using a couple of pictures. This, if anybody recognizes this monument with the Nintendo Switch photoshopped onto it, is Nelson's column. And our analyst Sharif likes to call this Nintendo's column. So when you're developing for a console platform like the Nintendo Switch, your design, development, test, and launch stages, and then your users down here at the bottom, the folks at the base of the column, they're all using pretty much the same devices. There may be some variations in what version of the OS or firmware that they're running, but there's only a handful of Switch consoles out there. for the public to use, which means it's a pretty one-to-one relationship between what the developer experiences and what your end user experiences. But when we look at the mobile gaming world, it's much more like a pyramid, where the design, development, and test phases, and this text is a little misleading, because really, if we're going to be honest, design, development, and test should be at the very, very tippy top of this pyramid. You know, we might run our games on a few dozen or a couple of maybe 100 devices, and we may be able to get some idea of what a real user is experiencing on those devices. But there's also the environmental factors that we have no control over, the other apps that are on the device, the operating system that is on the device, whether or not updates have been applied. And even if you have a device that is representative of a family of chipsets, there's different software, there's different hardware layers from the OEMs that get put onto it. So by the end of the day, the experience you have at the top here in your design, development, and test is completely different than what the majority of your users may experience. And that's kind of the main cause of this issue with performance issues getting out to the wild. Now, how do we fix this? I guess one answer could be to buy all 10,000 or so models of mobile phones and just spend years and years testing every aspect of a game. That doesn't seem very realistic to me. So at GameBench, we've identified a couple of different approaches, or one approach that has a couple of different angles, facets to it. The first thing is to come up with quantifiable performance metrics. The user reviews are a bad source of data for two reasons. The first reason has nothing to do with the quality of data. It's the fact that the user is the one catching it. You know, this is a really big issue because the problem is already in the wild. Your user's experiencing it. It isn't something that's been caught. So it's bad for that reason. And it's bad for a second reason. Most of those reviews are very kind of vague or nebulous, or, you know, they talk about larger compound issues that are made up of multiple performance issues that you may not be able to reproduce or quantify in a real way. And in fact, the only one of those reviews that we kind of looked at that mentioned any sort of number was that one Angry Birds AR review where they talked about 1% battery drain and per minute. And did the user, I mean, they seemed very passionate about the game. Did they actually sit down and measure the battery over the course of their gameplay? Probably not. That was probably just like a back of the envelope. This is my experience. It's really draining my battery. So we have identified the need for quantifiable performance metrics, consistent metrics and data that from one phone to another phone, one build of the game to another game, mean the same things, that you can actually derive some insight into how you're doing so you can accurately assess your performance. Part of these performance metrics are setting appropriate KPIs for your game and striving to hit them, understanding what are the key elements of your game's performance and actually putting them down in numbers. And this is game and user base dependent, because if you have a AAA title like Call of Duty or PUBG, you really shouldn't be comparing your load times to, or your graphical load on the GPU to a simple hyper casual game that is almost instantaneous from launch to gameplay. So you really want to set appropriate KPIs for your game and strive to hit them. Mentioned again, the reviews, they can be vague, they can be inaccurate. The end user doesn't have access to your source code, so they can't really like dive in and tell you specifically where your problem is. And a lot of these issues like lag, FPS drop issues are actually a bunch of different performance bugs kind of working in concert to cause lower performance for the end user. And that's why we say good data isn't enough. You really need actionable intelligence. And to contrast actionable intelligence with those user reviews, actionable intelligence is data at as many stages of the development lifecycle as possible. So not just at the end, not when it's in the user's hands and they're complaining about bugs or issues or you know, load time, frame rate, all that stuff. Catch it as early as possible and make it as ingrained into the development lifecycle as anything else with your game, so that everybody is on the same page. And this is important because not only does it prevent bugs from getting to end users, which affects the business performance of your game, the earlier you catch these issues, these regressions, it's a lot cheaper to fix them. If you catch something, if something never leaves a developer's desk, if it never goes to QA, if it never goes into soft launch or beta, it's a lot easier to fix it. It's a lot cheaper because it's fresh on the mind of the developer that caused the regression. And then actionable intelligence has to be actually actionable. It has to be relevant to the party that's looking at it. So for a developer, they may want to see that their CPU usage is over 10%, 15%, you know, and they can go back and they can look and they can see, oh, I added this very complex physics calculation and it's really spiking up my CPU usage. But to a producer or to somebody that's working on live ops, you know, CPU being 12 or 15% isn't necessarily relevant. It isn't I mean, it's important, but it's not something they can really grasp. They need to see, oh, this is going to affect this subset of users based on our demographics and our live ops data. It's going to affect 30% of our low to mid-tier devices. They're going to be interested in that data. So it has to be appropriate and actionable for all the stakeholders. So that's how we define quantifiable performance and actionable intelligence. So I'm just going to take a quick look at the chat and questions, and I don't see anything here, but again, I encourage you, if you have any questions, if you have any comments, please just drop them in the chat or in the question section, and I will answer them. So we have actionable intelligence, quantifiable performance metrics. Let's talk about quantifiable performance. And this is a good example, frame rate. Frame rate is one of the most noticeable user metrics, especially if you're dealing with any sort of game that has any sort of real rich animation. Fluidity, frame rate consistency, it's one of the most noticeable metrics. It's literally what the eyeball of your user is seeing and experiencing. So the problem or the difficulty with frame rate as a metric is that it's actually, while it's super important, this isn't something that really gets you into what the root cause of these issues are. So you can see this blue line is actually representative of frame rate, and this happens to be PUBG, where we can see noticeable dips, and then this black line represents janks. This is where there are issues with missed frames that are causing a breakup in fluidity of the visual picture. So frame rate, like I said, it's caused by a number of sources. It could be a CPU issue, it could be a GPU issue, it could be a network issue, depending on the how the game was coded or conditions on the ground. But it's very important to actually capture this and have quantifiable numbers around it, because now you can highlight these areas and dive into other quantifiable performance metrics and see where the contribution to the frame rate drop is coming from. And a lot of times it's coming from CPU usage issues. And CPU as a metric relates to so many performance issues. We just mentioned frame rate drops, heat on a device. There are a number of really, really negative reviews that we read on a constant basis where people are complaining about their devices getting hot as they hold them in their hands. Battery drain. Again, it's directly tied to heat and CPU, because the harder the processor is working, the more power it's putting out as waste heat, which means it's draining the battery faster. Unresponsive UIs, if you're doing some very, very complex physics calculation on the main thread, you can actually end up with a UI that's unresponsive, or issue that could be related to CPU performance. And the really cool thing with modern devices is that we're getting faster and faster and more powerful, and we're getting more and more cores. So they present these newer devices like the Pixel 4 or the Apple iPhone XR. They have multiple cores at different clock frequencies. So they present really unique challenges, ensuring that you're running your main thread on the fastest possible core that you need. But they also present really unique opportunities to look at multi-core development, multi-processor development, parallel processing, splitting jobs up. And it's a really exciting time to be optimizing for CPU. And when we look at CPU usage, that has a similar kind of effect like frame rate does, where other metrics, other elements in the computing process can cause spikes in CPU usage. So two of the most frequent things that we see are memory usage issues and network usage issues causing spikes in CPU as well. So memory usage could be something like a cache miss or just very poorly architected data. Disk I/O, where you're transferring a lot of stuff from storage into memory back into storage. And then network with CPU, all of those packets that you receive, they have to be processed somehow, and your CPU is the one that does all that work. So let's take a look at another thing that kind of contributes to, well, definitely contributes to frame rate droppage, and that's the GPU. And just like CPU, it relates to a number of performance issues that your users directly see and impact, and they'll write a negative review if they start seeing that. So you'll start seeing frame rate drops, and again, heat, because GPUs, they're getting beefier and beefier on these embedded chipsets, and they're doing a lot of calculations, and there's a lot of waste heat. And again, that gets you into the battery drain territory. So optimizing for your GPU usage, making sure your textures and your assets and your geometries and your shaders are, one, accomplishing the goal of your game, creating something beautiful that's visually pleasing for your end users, but two, are as optimized as possible. If there are LOD tricks that you can use for a complex 3D model, make sure you're not doing iceberging or any other issues around like occlusion culling, just making sure that your graphics pipeline is as streamlined as possible to hit that quality of graphics performance that you're aiming for is critical when you're looking at the GPU. And again, GPU usage is tied to other metrics. It can be tied to issues with your CPU. There can be issues with the way that your CPU is handing off data to the GPU. Your memory usage, disk I/O, if you have particularly slow flash, loading large complex models consistently can cause issues with GPU. Memory, again, we're talking about quantifiable performance metrics. Memory is a huge one. Issues with memory and memory access really tie into a number of user noticeable things: frame rate drops, heat, battery drain, and crashes. Memory is probably one of the biggest issues around crashes, where you use too much memory and then the operating system comes in and just smacks you down. Says, look, you've exceeded your envelope. Now you're in an ANR state. Goodbye. And load times, load times are a huge issue. A lot of users complain about them, and that's directly tied to memory. How much are you taking off of the disk and putting into memory? And when we talk about memory, we're talking about a wide variety, just like with GPUs or CPUs for that matter. There's a huge variety in the quality, speed, and capacity for memory. And you have to kind of account for that when you're doing your testing and development. You have to think about, not everybody is running the latest iPhone, not everybody is running the latest Pixel device or the latest and greatest from Samsung. So memory usage spikes are critical to catch early on and think about in terms of how your assets are optimized, how your data structures are organized within your code, and how if you're using a managed language or a managed framework where you have garbage collection, how are these things being triggered? Where are they being triggered? How can we control them? So that's memory. And I'm just noticing a question here that somebody asked about, is there any standard number for GPU usage? And unfortunately, the answer is going to be like a lot of the answers around any of these metrics. There really isn't a standard. It's going to be game and genre dependent. So if you're building something that is incredibly complex, like a PUBG, Call of Duty, Modern Warfare, you want to have all of these fancy 3D models and textures and particle effects. You're going to have a pretty high GPU usage. There's really no way around that. And with the way that mobile devices are moving, and it's just like with anything in computing, the more capacity you give a user or a developer, the more they're going to use it. So if you tell me I've got 32 gigs of memory available to me, I'm going to use 31.5 if I can get away with it. So with GPU and most of these metrics, there really isn't one standard number. What you have to think about are your competing titles, the other folks in your genre. How are they performing? What types of loads are they experiencing when it comes to the GPU or memory or CPU, any of these metrics really? On what are the low-hanging fruits for you to grab to make sure that your GPU usage is as optimized as possible? So that means like looking at draw calls and trying to determine where you're burning extra cycles, rendering geometries that your user may not even see. And then again, I would refer back to really using your competitors, the industry as a whole, as a benchmark for your GPU usage numbers. Because if you're developing, say, a Tetris clone or a word game, and you notice that your GPU usage is 20 to 30% higher than your competing titles, you might want to start looking at some optimization techniques there, because you're going to experience those issues around battery drain and heat that your competitors won't. So I hope that answers your question around standard number for GPU usage. And again, this kind of extends to any of these metrics. So we just talked about memory, answered the question about GPU. Let's talk about network. And network is one of the most frustrating sort of metrics to work with, because a lot of it's out of your control. So network usage, it relates directly to a number of performance issues. Load times, because if you're stuck spinning on a service, an external API to serve an ad or log a user into like Apple's game service or Google's game service, that can actually slow down your load and really negatively affect your user. Heat, every time you turn on that radio, whether it's the Wi-Fi or if it's the cell radio, you're causing power issues, and you're going to end up causing heat to be an issue there. Battery drain, poor network conditions, when you have 1 or 2 bars of service, or you're in a poor area or a crowded region, your radio has to work harder and use more power to accurately transmit and receive that data, causing your battery to go down. And then, like I mentioned before, all of the data that's transferred over your network radios, that has to be processed somehow. So your CPU is doing some sort of work on it, and it's going to cause CPU spikes, especially if you're processing some large chunk of data that's just come down from an API or external service. And to complicate things, your games are probably deployed worldwide, being played in a number of markets. Users are on all sorts of networks. They're on 4G, they're on Wi-Fi, they're on 3G, and the quality of these networks is a huge issue as well, where you have, somebody could say, I've got, solid, beautiful Wi-Fi performance. It's got 4 bars for my Wi-Fi, but they don't realize that that's just the connection from the device to the router. Their mom is streaming The Mandalorian on Disney Plus, and their dad is watching something on Netflix, and their sister is, playing an intense MOBA game or something like that. So there's a wide variety of networks that are out there. And then the worst thing is when people use network radios inefficiently. They constantly wake the radio up or shut it down, and that causes those spikes in CPU power and battery and memory issues. So I just noticed a question on, a couple of questions come in. With GameBench, how do you deal with hugely varied average memory usage data? Looking at whether or not you can attribute something to a change. And I'll get into, I think I'll have an answer to that question just a little bit later when I'm talking about sort of the actionable intelligence and how you design your tests. And then the next question I'm seeing is, observe games suffer loading while on mobile data, but works fine at Wi-Fi at the same bandwidth. How is that possible? There are a number of different ways that could be possible. There could be some QoS stuff going on the mobile side, where the network operator is deprioritizing that traffic. So you may have the same upload-download speeds when you're doing like web browsing, but it could be an issue there. There could be a number of issues, and that really gets to the kind of the heart of the network discussion around, it's two completely different radios, and two people sitting right next to each other can have, they could both be on a cell modem. They could have completely different experiences just depending on their network, whether, and a couple of other things around that. Sorry, I lost my train of thought there. Two people sitting next to each other could be on completely different cell networks and have completely different experiences of the game based on congestion, trafficking, traffic, QoS, all that information there. Okay, so these are some of the big contributors, some of the big metrics that we look for, and we want to be able to quantify it in a real way. Frame rate, CPU, GPU, memory usage, network. Those are the big 5 for us when it comes to mobile games development. So I'm gonna throw out a picture here, and if anybody can recognize or knows what this cord is, this gentleman here in this factory is pulling down on, just drop it in the chat. I'll give you guys a couple of seconds to think about that. Well, nobody seems to be dropping anything in there. So what this is, this cord, it's called an andon cord. Just a little bit about me, my background, my first sort of gig out of college was working in the automotive industry, doing a lot of process automation and process improvement. And the andon cord is something that comes from Toyota. So if you go to a Toyota car assembly factory, you'll notice
as the car, starts as a frame and has the different parts bolted onto it and added and painted and et cetera, et cetera. These are huge, massive factories. There are these cords that run along the assembly line. It's called an andon cord. And anytime an assembly worker, this is somebody that's not an engineer, they've been trained to do 1 or 2 jobs in the plant, whether it's installing a door or putting a floor mat in, anytime they run into any issue whatsoever, they pull on that andon cord. And what happens is the entire line stops. This is what I like to call actionable intelligence, where one worker in one part of a huge assembly can stop the entire thing because they notice one problem. And this focuses everyone's effort to solving that one problem. Everybody runs over, they go and they fix the issue. So if somebody is installing floor mats and they have difficulty getting the locking mechanism for the floor mat to actually secure it to the floor, they'll have the factory stop and then workers come out and diagnose and fix that problem. And in fact, about 10 years ago, when Toyota had some recall issues around stuck accelerators, part of the problem was that the worker that was working on floor mats didn't pull the andon cord. And what ended up happening was these floor mats were slipping and then sticking the accelerator down, causing some runaway acceleration. So for me, this picture is what I would like to bring to game development: actionable intelligence, where at the point of an error, we can stop and get the resources around it to fix it. So what does that look like in the course of a game's life? The first part where we should start thinking about performance is in game design itself. So this gets back to what I was talking about earlier in terms of setting target KPIs for your game and your genre. So making sure that what you're aiming to accomplish with your performance goals matches or beats your competing titles. You want to be faster, better than your competition. So getting everybody involved at the very beginning when you're writing your game design document and saying, we're going to eat Call of Duty's lunch when it comes to memory usage and battery drain is really important. It gets the entire studio on board for performance in the game. And then as you start thinking about the architecture of your game, start designing or thinking about it with performance testing and automation in mind. I just visited a couple of studios over the last few weeks that this is becoming a bigger and bigger part of their game design process. They're looking at, how do I replay certain sections of a game or create small bite-sized chunks of a level so I can accurately reproduce issues. So this kind of gets back to the question that Morgan had asked around with getting varied average memory usage data. Ensuring that you've properly architected your game for replayability and automation testing is key to making sure that you can get reproducible measurements as you're going through the game development process. And then when you start thinking about this from an architectural perspective, it helps you to identify areas where automation and testing are going to be very difficult. So if you have a game where there are big sections that are non-deterministic, this is where you're going to want to flag that and know throughout the entire life cycle, this is a problem area. This is where we're going to have more difficulty monitoring performance usage. Everybody's on board, everybody understands it. And it's also a really good time to make that case for why performance matters, getting buy-in from all the stakeholders, from the designers to developers to QA to live ops and producers as well. So it starts at game design. But I want to emphasize something here. It doesn't mean that everybody who's got a game out in the wild right now is they've lost. That's not the case. If you're architecting a game, you're working on a game right now, now is the time to start thinking about it. But there are actionable steps that you can take right now through the rest of your game support cycle and development cycle to really fully utilize the power of those quantifiable performance metrics. So when you're in the game development phase, when the devs are actually building your games, these metrics come into hugely powerful to prevent performance issues from reaching the wild. And I like to think about this. I like to think about performance testing like good developers treat unit testing. And there's a reason I put good developers in there, because unit testing, I know there are some bad developers out there who don't like to use it, or they write the worst unit tests ever. So treat performance testing like good unit testing. This is something that you write and you think about before you write code. Think about how your next feature, your next thing is going to impact the performance of a game. If you're adding a boss and they've got these particle effects, think about what the performance impact is going to be on GPU usage or CPU usage. If you're loading this incredibly complex mesh, think about memory load times. If you're adding a new network service, think about power, think about the amount of data that you're transmitting down and the bandwidth. And then the developers themselves, they'll be able to identify the areas in their code that are non-deterministic, which are really hard to create reproducible bugs or reproducible issues with. And again, this gets back to the raising a flag saying, hey, when you get to this section of the game, it's going to be a bit harder to test. And then in development, making sure you're following best practices around clean state management and having a great game state manager is super important, especially when you're trying to create something that's reproducible and automatable. And this last point, which I highly recommend to everybody here and anybody who's going to listen to this, is to integrate your performance testing into your CI systems. Just sanity checks, make sure that you're meeting minimum thresholds for FPS, memory, network if you're using it, GPU if you're really hammering on it. Just add those sanity checks in, so that way you catch them at the developer's desk, not on your user's phone. When we get into compat testing, when we're getting closer to team CI, somebody just dropped that in there. So some studios will have a continuous integration suite for the actual dev themselves at their desk, and then for the repo, when somebody wants to commit something in, they would have a separate build pipeline for verifying performance. So CI is continuous integration. I'll hop back right quick. So what continuous integration is it's a way of standardizing a build process for a game for developers. If anybody's worked in development, there's a common experience where someone says, well, the game builds on my machine, it doesn't build on your machine, that's your problem to deal with. A CI standardizes all of that and allows, it kind of enforces everybody to build something that one machine can actually, or write code that one machine can actually build and create as an executable. And then you can also write tests on that CI system and make sure nobody is breaking the build. And if somebody does break the build, you can blame them, or more accurately, give them the opportunity to redeem themselves and fix their issue. So compat testing. So actionable intelligence here. I think compat testing is a really interesting area within a studio where you have a lot of coordination and collaboration potential between your live ops team and your dev team. I think this is an area where there should be a lot of communication and unity around what's happening here. So use data from your live ops team if you've got an existing game out there, or if you're developing a new game. You're going to have some sample data, hopefully, around what your user demographics are, what devices they're using, where they're located at. So use that information to make sure that you've got a representative sampling of devices in your compat testing. You know, you're not going to be able to do testing on all of the 10,000 or so devices that are out there. You're going to have to make some selections. The better data that you have from your live ops team, the better you're going to be able to emulate that in your testing environment. And then it really comes down to training your testers the best that you can to really understand the performance testing tools that are out there and to recognize specific performance bugs. You know, we're starting a GameBench certified tester program to really offer that training to test teams, to make sure QA teams, to make sure they're really understanding the performance issues and how they can identify them, how they can mark out the sections of the sessions where those performance issues occur, and create usable, actionable intelligence for the developers that have to fix the bug, and then be able to raise the flags when, you know, there is something seriously wrong performance-wise that's going to impact user perception of your game, that they can raise it up to the live ops and producer level. And then again, like I said, the compat team, I think, is a great place for a lot of communication and collaboration, really can join two sides of the studio together. So sharing those captured sessions with developers on bug reports, making sure that your compat team has the same KPIs and minimum thresholds that that match your live ops environment and what your users are actually experiencing. It's a great opportunity for real actionable intelligence here. And then when it comes down to it, you've got to release the games. And we really recommend using an independent testing service to verify your release's performance. When you're a developer, when you're a compat tester, you're looking at the same game day in and day out. You start to kind of develop blind spots to bugs and issues in the game itself. Having fresh eyes to look at something is always good. That's why pair programming and code reviews are such a big thing in the development community. It's because you want to have somebody who hasn't kind of ingrained some of the biases by being so heads down into it, look at it and see what's going on. And that's actually a service we offer here at GameBench through our labs division, where we can help you compare your upcoming releases to your titles, and then creating an actual release report where you have information that's accessible to all of the stakeholders. So for the developers, they're going to want to have the raw session data. They're going to want to look at the numbers. You know, I'm a developer, give me numbers any day of the week. But for a producer or for somebody that's higher up in the chain that's thinking about business performance, something like these badges, clear, very quick, communicates a lot of information. A matrix of these badges of your game compared to a couple of competing titles across a variety of devices makes it very easy to see, oh, hey, we've got a bunch of red and our competition is all green and blues. This release can't go out. Or the flip side, hey, we're rocking green and blue and everybody else is at yellow and red. This release is going to be awesome. So release verification, it's an incredibly powerful part of actionable intelligence for your studio. And then when we get into the live ops environment, active user data, looking at monthly active users, daily active users, and if you have live performance reporting from the wild, beginning to make those correlations between bugs that are being detected, crashes that are being detected, and drops in DAU and MAU is important. It's huge. It'll help you make the case for making a bigger investment in catching performance issues earlier on. Demographic data, so knowing who your users are, where they're at, what types of phones they're on, the networks they're using, will help you with where you want to place your CDN systems, where you want to place your asset servers, the size of your assets that are downloaded. You know, if you know that a lot of your users are on lower quality connections, 3G, lower speed 4G connections, maybe break that 3 gig asset pack up into, you know, 6 500 megabyte downloads, or even smaller yet, because, you know, the quality of the connection is so poor. Looking at user feedback and those reviews, I can't tell you the number of times we went into studios and showed them that Purview tool with the reviews and then the grid of the different issues, and the studio, the lead that we're talking to looks at it and goes, "Oh wow, I've never seen this before. This is amazing." So really paying attention to what your users are writing on the Play Store reviews, and then if you have a community component to your game, or a forum, or if there are dedicated sort of user sites where people talk about what your game, the quality of your game and playing your game, being engaged and having your finger on the pulse of what people are talking about is massively important. And then the other thing is, and this is probably the biggest takeaway for live ops, is to share this data with everyone on the team. It's really easy when you're a dev or a compat tester, or you're working in design, or you're an artist working on assets, to kind of just get focused on that. But to actually see your successes of, hey, our users love the work that you've done, and you guys are doing so much better than our competing titles when it comes to things like load times, assets, graphical quality, smooth frame rates, CPU data usage. The batteries are lasting longer than your competitors. It's really inspiring for everybody on the whole team. So I think that covers all of the actionable intelligence, going through the entire flow of a game development cycle. And again, all that stuff ties back into the quantifiable performance metrics that you need to have to really measure a game's performance. And I see a question that just came in. Where's my mouse? Yeah, latency is part of performance, and latency is one of those things when we're talking about things like load time, where it can be tied to a number of different factors. It could be a CPU usage issue. It could be a network issue. So these core performance metrics are part of performance. The core performance metrics make up some of these bigger user issues around like lag, latency, glitches, or crashes. I just wanted to kind of highlight the sort of what we consider the 5 basic performance components. They all make up these larger issues that your users will see. So I hope that answered your question. I just wanted to throw out, this is the first of a series of webinars, and I've got a handful of topics up here that we're planning on talking about in the coming weeks and months. So, everything from basic stuff around memory utilization and optimization, so things like object pooling, recognizing when you have inefficient memory usage and optimization. Yeah, and then CPU optimization, and I'm really excited to talk about multi-core programming. My work in undergrad was on designing massively parallel systems, and believe me, I know a lot about, and I've experienced a lot of these fun challenges that come up when you start splitting up work across multiple cores. Networking, that kind of touches on the issue about latency. Let's do a little bit of let's actually take the game engines and let's do a performance shootout. Let's do some benchmarking. You've got to find a way to pay for your game. So you have ads, you have these other networks. Are they actually hurting your game's performance? And then the next two, really interesting to me. This is, I think, indicative of the larger trend in the industry to push towards performance. Unity has done some great work on creating tools and ecosystems to create faster games specifically for mobile. So ECS and DOTS, which is their entity component system and their data-oriented tech stack, are there actual gains that can be had there? And then the new, I guess they're calling it their universal render pipelines. So
let's take a look at the render pipelines. And then again, as I said in the beginning, I'm a big fan of XR experiences. There's some really cool tools out there for building XR experiences, especially for Instagram and Snapchat. And we can take a look at how to build this out. So you know, I just threw out a whole bunch of these topics. I'd love to talk about them, and believe me, I can talk about them. But I'm interested to hear what you guys want to see, and if you want to vote on, you know, a topic, or if you're really passionate about, say, network latency, or you have a specific question that you're running into with one of these topics, again, email me, eli@gamebench.net, eli@gamebench.net. I would love to have your feedback and participation on these topics. So please reach out, let me know if there's anything that you would like to see in addition to these topics, or if you really have a burning desire to see one of these. These are in no particular order. With that, we'll open it up to Q&A, and I see our first vote for topics around CPU optimization and multi-core devices. Yeah, I'm really looking forward to that one. So that's great. I see a question asking about the difference between using Android Studio and GameBench. So there's a couple of really big differences between Android Studio and GameBench. The first one is that Android Studio can't profile iOS devices, which is kind of important. And when we talk about GameBench, we have multiple tools. It isn't just the desktop app or the Android app that we release. We also have an SDK, we have an automation solution, and our lab services. So Android Studio can get some performance metrics for you. It doesn't log it to a unified dashboard. It doesn't allow you to do build over build comparisons. It doesn't allow you to do filtering by device, so you can't tier or group performance runs together. You know, I think it's a great tool. A lot of the profiling stuff, any development community or tool comes out with, I think is great. But GameBench really presents a unified interface for capturing performance data and then actually being able to pull it together in a way that gives you actionable intelligence across, you know, multiple devices, multiple builds, and gives you a solid history of that data so you can actually track performance regressions. So I think that's how I would describe the difference between using Android Studio and GameBench's tools. Okay. Next question. Apart from CPU, GPU, memory, and battery-related metrics, are there any other metrics we should take a look at? Yeah, network is a huge one. Just understanding, and when I say network is actually kind of a group of multiple metrics. There's the networking metrics around just when are you waking up the radio, when are you turning the radio off, the amount of data that's being transmitted back and forth across the radio, and where you're talking to, because if you're in Brazil and your assets are if you're a user in Brazil and the game's asset server is in Northern Europe, the transfer speed is going to be pretty slow, which means the radio is going to be on for longer. It's going to hit you on power, and that also ties into load times. Understanding, you know, how long it takes to go from level to level, or from the launch of your game to the first interactive screen. Those are huge metrics that you should be looking at, and those sorts of things like load times or flows through a in-app purchase experience or allowing someone to actually get a premium item in your game, they all are kind of these like composite metrics. They're made up of the underlying issues with GPU memory, networking, power. It isn't usually, it's very rare that you can have one of these issues like with frame rate or with load times where you can say it's this one specific thing. It's this one lever that you have to push and then your entire game is fixed. It's usually a mixture of a few things: CPU, GPU, memory, network, disk IO. So yeah. All right, I hope that answered your question there. Yeah, do we have any other questions? If so, please feel free to drop them in the questions or into the chat. And we went a little bit long. There's a slight of, we started just a little bit later. Wanted to make sure that everybody who wanted to join could join. I want to thank everyone for joining today. Thank you so much for spending some time with me, talk about why performance matters. Again, I'm gonna go back to that topic page. Shoot me an email. Let me know which of these topics you'd like to learn about next, and I will be glad to correspond with you. And I look forward to seeing everybody. And I just saw another question come in. Can GameBench be used for cloud-based testing of mobile devices? Yes, and we will cover that in a future webinar topic, or you can reach out directly to me and I can talk to you about that. But yes, we do have a solution for cloud testing that we are actively developing and working on, and would love to chat with anybody who's interested in cloud-based testing, because again, like I said at the beginning, I am all about automated performance testing. So it's something I really care about. Please shoot me an email, eli@gamebench.net, with any other questions or topic ideas or anything else. With that, again, thank you so much for coming out and listening, and I look forward to seeing you on the next webinar.